1.3 hour. This is going to involve some more advanced exponents problems. That means it's often going to involve a combination of different rules. And so BEDMAS is going to be our guiding principle there. We're just like when we learned about operations and then integers and then fractions. BEDMAS always came to be our guiding force when we had multiple things to do. And then also we're going to have some integer exponents. And the word integer is a word that means positive and also negative counting numbers. So that means we're going to have some negative exponents. And so we'll see some problems that involve those. And then eventually we're going to have some negative exponents thrown in with all of these kind of BEDMAS-y bigger questions as well. All right. So when we do a BEDMAS problem, we're going to start by doing everything we can inside the brackets if we can see anything to do inside brackets. And there's a little nuance here. There's also in the bracket step, we consider the top or the bottom of a fraction also to be within brackets. And they're not obviously actually in brackets, but it's true that necessarily this statement, x plus 14 in brackets divided by 6, is actually equivalent to this statement. Both of them really say that both 14 and 4 are being added together and then divided by 6. Those are just two ways of saying it. So in both cases, we have to add 4 and 14 before dividing by 6. So both times we would get 18 over 6. They're both equal to 3. Anyway, so that's also a bracket step. And so that's actually a really key idea here. Now, I'm not in the normal room that I normally record these videos. So I noticed two things. First of all, I'm next to a room that actually has a bunch of students in it. So if you hear any loud noises or interruptions today, that's why. And also the table does this. Moves back and forth. And actually I can see the camera kind of moves in the same way that the table does. Actually, maybe I can fix that before we get started here, because I could see that being a little distracting. Let's see what we can do. Alright, so it's still a little not perfect. Well, I don't know how much I'm going to fix it, so I'll just try and write peacefully so I don't cause any shaking. Alright, after we do any bracket step, we'll distribute any exponents that we haven't done already, and then we'll do any division or multiplication. Alright. So if we look in this question, well, the first thing we might look to say is, can we do anything inside the brackets? Inside brackets. And it looks like I can't really do anything inside this bracket. I've got an a cubed, but I don't know what a is, so I can't cube it. And in this bracket, I don't know what a is, so I can't raise it to a power of 4. So there's nothing I can do in either bracket step. So the first thing I'm going to do actually is an exponent step. I'm going to distribute this exponent into this bracket here. So that means I've got a cubed to the power of 2, which means a raised to a power of 6. And that's times a raised to the power of 4 times 5, and that becomes a to the power of 4 times 5, or a to the power of 20. And then I move along my BEDMAS rules, and I've done my exponent, so I'm going to move on. I don't have any division, but I do have a multiplication. And my multiplication rule says I add the exponents. So we have a to the power of 6 plus 20, or a to the power of 26. All right. Next, we will take a look here and say, okay, well, I don't have any brackets here either. However, I do have something that's like brackets, which is to say I have a fraction, and I have operations I can do on the top of the set of brackets. And so as a bracket step, which I'm going to label brackets, I'm going to do a little multiplication inside the brackets. Of course, there aren't brackets, but I'm calling it a bracket step. So I'm going to add these exponents together. I've got b to the power of 15 over b to the power of 3, or b cubed. And then I don't have any more exponent steps I can do. I can't raise b to the power of 15 or b to the power of 3 because I don't know what b is. But I do have a division of 2 powers, so I can do a division step. And that's to say that'll become b to the power 15 minus 3, or b to the power 12. All right. So let's move on here. I can see, looking at the screen here, that maybe this doesn't resolve super clearly. I think I'm going to zoom in for this next one. I think I'm going to change my pen so it's something that doesn't bleed together quite as much. I feel like it's tough for you to see that 15 on the video. It maybe wasn't that tough, but I want to make it was like borderline, so maybe we'll zoom right in. There we go. And I think I'm going to focus the screen again just to make it a little bit nicer here. So I'm not going to have bed mass written up there anymore, so we can't see it on the screen because we're zoomed in. But we remember that we do bed mass first, so we're going to do anything we can inside brackets. So I can see for this question, I can do some bracket steps here. So I can do c squared times c cubed. And when we multiply powers, we add the exponents. So as a bracket step, we're going to rewrite this inside the bracket as c to the power 5, 2 plus 3, squared, over, and I can't really do anything inside the bracket down here, so I'll just leave that as c cubed, squared. Now, I can also do another bracket step. I think maybe to make it more obvious in my notation, I'm going to call this sort of bracket step a quote-unquote bracket step. Oh, sorry, that is actually a bracket step. We really did something inside the bracket. But the next one is like, we call them brackets, scare quotes, but they're not really brackets, which means we can resolve something on the top and the bottom of a fraction. In this case, I know that c to the power 5 squared is c to the power 5 times c to the power 5, or c to the power of 10 over c to the power of 6, because I multiply these powers together. And then lastly, I'm going to do a division step, which is I'm going to subtract the powers, and I get, extract the exponents, subtract the exponents. 10 minus 6 is 4. Okay. All right, so next. So we don't have anything inside brackets for a bracket step, but we do have a quote-unquote bracket step. We can do quote-unquote brackets, meaning the top of a fraction. And I can do stuff up here. So I've got quote-unquote brackets. I've got multiple operations. I've got a multiplication, and I've got an exponent here as a set of brackets. So I'm going to do our exponent step first of inside the bracket before I multiply inside the bracket, because bed mass applies even inside a set of brackets. All right, so I'll do the exponent first. So I'm going to say that's x cubed times y to the power 4 times, and I'm going to distribute this power of 2. So the power of 1 there, so it means x squared times y times x squared times y. So it's x raised to the power 4 times y squared. That's all over xy cubed. And now I'm going to do a multiplication step inside that bracket, inside the top here, meaning I'm going to multiply these suckers together, and I get x power of 3 plus 4, or x power of 7, times y to the power of 4 plus 2, or 6, over x y cubed. And those are both sort of inside the bracket, meaning anything I can do is on the top or the bottom of a fraction. And so let's move on. So our next step is just looks like we could have a multiplication here, but we can't really multiply these guys together because we don't have a rule for what to do if our bases are different. All right, so the last thing to do here is we're going to do this division. I can see I'm dividing these x's and these y's. So we're going to do a division step. We get x power of 7 take away x to the power of 1, or x to the power of 6, and y to the power of 6 divided by y to the power of 3 is y to the power of 6 minus 3, which is 3. All right, next one gets a little heavy. So again, I might look inside the brackets and see I can't really resolve anything inside the brackets really, but I can do a quote-unquote bracket step, so to speak, which is to say I can do, I'll just label that quote-unquote brackets. So I got an exponent expression inside, 2 exponent, 3 things I can do that are like quote-unquote bracket steps for exponents. So I'm going to resolve all the exponents inside the brackets, or rather on top or bottom of the fraction. So that's I'm going to Now, next, we're going to see if we can do any multiplication also in this quote-unquote bracket step. So we're going to multiply across here. So it's going to give 32, which is 4 times 8. And I can't really multiply my x's by anything, so it just says x power of 8, but I have y to the power of 4 times y cubed. 4 plus 3 is 7. And then on the bottom I have a 2 times an 8, which gives us 16. And I like to write my terms in alphabetical order, so I'm going to write my x squared to the power of 6 first, and then my y raised to the power of 4 next. All right. And then we're going to do a division. Oh, and that was a multiplication step. Then we'll do the division. And that division, we're going to have 32 divided by 16. It's going to give us 2. X power of 8 divided by x power of 6 is going to give us x squared, because we have 8 minus 6. And y to the power of 7 divided by y to the power of 4 is y to the power of 7 minus 4, which is 3. Okay. So we'll move on. We're going to do some questions that have negative exponents. And the rule is, this is an arbitrary rule invented by math teachers, that when we say simplify, we mean there are no negative exponents when we're finished. And that's going to be really key. All right, so the first question really asks, do you know the exponent law for negative powers? And we do, which means we got to rewrite the reciprocal of the base. We have 1 over x. We raise it to a positive 5. So we flip, and we reverse the sign. All right, so here we have a few things going on, but I guess the first thing we should do, actually we could do this in 2 different ways. I'm going to solve it in 2 different ways. The first way I'm going to solve it is by ignoring the negative for now and just using our exponent rules. We have a division step here, right? We can divide x power of 2 divided by x power of 6. That'll give us x power of 2 minus 6, which is x power of negative 4. And y to the power of 4 divided by y to the power of 3, which gives us y to the power of negative 7. Negative 4 take away 3 is negative 7. And where's my red pen? There it is. And then we have these 2 negative exponents. So both of them need to be flipped downstairs into their sort of reciprocal form. So then we actually write that as 1 over x to the power of 4, y to the power of 7. So that's one method we could do. We could do that flipping of negatives after. Or we could solve this another way. We could take the negative exponent we see here and flip it downstairs first. And that's fine. So that looks like we have x squared over x power of 6. Then we have y cubed times y to the power of positive 4. Okay, and then we have like a division between these fellas and a multiplication. So you might then, I guess there's actually a couple of ways I could see to go here, but without introducing too many tricks at once, I'm just going to use my simple division rule and subtract the powers there. So x power of 2 minus 6 is x power of negative 4. And does that go on the top or the bottom of a fraction? And the answer to one of those division questions always ends up going on top. So it always goes on top. And that'll become x power of negative 4. But our y to the power of 3 times y to the power of 4, those are downstairs. They're down in the denominator. So we're going to end up down here. And that's great, but now we have this other negative exponent, which we could actually flip downstairs. And so that actually does leave us with a 1 on the top still, and an x to the power of positive 4 now, times y to the power of 7. Now, those are the same answers. And this may have seemed like a little bit of a futzy way to go about things. So it's not necessarily that useful in this case. However, you might have also noticed there's a relationship here between these x squares and the x power of 6's, where you could have thought of it as x times x on the top, and x times x times x times x times x times x on the bottom, right? That's what x power of 6 really means. And then there's these y cubes on the bottom. Y times y times y times y times y times y times y. And you might notice that you can cross out these squares here and these guys here, and that leaves us with x to the power of 4 on the bottom and y to the power of 7 on the bottom. X power of 4, y to the power of 7. There are people screaming in the hall, so please excuse me. All right, I do apologize for that. Now, we'll proceed here, and we can really use, I guess we saw a few different kinds of reasoning we can use to approach a question like this. If you see negative exponents, you can actually maybe flip them first if you like. And actually, I would say that works sometimes. That's what we did in this method. We flipped them first. In this method, we just used a division rule first, and we didn't care that we had negatives. And then at the end, we flipped negatives. And that actually worked out pretty tidily. And if you use a combination of these two rules, there's actually a faster way to go through things. But it takes a little bit of time to feel the nuances for those sorts of situations. All right, so anyhow. I think maybe we'll use the same method we use here. We'll just do some blind subtraction or division rules, and then we'll just flip anything at the end. So we've got x power of 8 divided by x power of 10, so that's x power of negative 2. And y to the power of negative 2 divided by y to the power of negative 6, which gives y to the power of negative 2 minus negative 6 is positive 4. Negative 2 take away negative 6. It's an easy one to get caught up on. And that actually gives us x power of negative 2 times y to the power of 4. And so that actually means we only have one negative exponent here in this case. So we're going to take that guy and flip it downstairs. We're going to rewrite that as y to the power of 4 over x squared. All right. It's really bugging me how much this camera is shaking. So, I apologize for that. There's got to be a better way to see this. Just shake it all over. Let's try this. I hope that'll make it shake a little bit less. Alright. I promise you it's only this video that'll be doing this. Actually, you know what? I don't know. I'm not in 308 as much as I once was, so maybe it won't be just this video. Alright, so what can we do here? So it looks like we got a couple of things happening. Should we distribute the negative 3 in first? Should we flip this guy down to the bottom? Should we flip the whole thing under 1 and then say it's all that bracket to the power of positive 3 under 1? Several different methods. What I think is probably the best approach for as we're learning this stuff, and maybe if you want to experiment with some order and flip around some things and find a method that works for you, then you can do that, as long as you get to the same answer. what I'm going to do is I'm just going to do some distribution here. I'm going to say I'm going to distribute this negative 3 into, well, first I'll do the brackets. Doesn't look like there's any thing I can do inside the bracket, so I'm going to move on to the exponent step. I'm going to distribute a negative 3, and I'm going to multiply both of these by negative 3. That'll give me x to the power of negative 6 and y to the power of positive 12. And so that's pretty good. Then we have a negative exponent. So we have to flip this downstairs, and that gives us y to the power of 12 over x to the power of positive 6. Good. All right, let's move on. We have this last question, question E. And so I can see that if we do some flipping first, I can see how it would be faster, but I think you can experiment with seeing which situations where you flip your negatives up or down makes your life easier, in which cases it makes it harder. Make sure you get to the right answer at the end. All right, I'm actually going to just do a division of each of these steps first. So I'm going to do x to the power of 3 divided by x to the power of 5. So that's going to be x to the power of 3 minus 5, which is negative 2. We've got y to the power of negative 2 take away 4, so that's negative 6. And z to the power of 6 take away negative 3. And I'm writing out the take away negatives as an extra step because that's a really common way to get a little mixed up there. 6 take away negative 3 is actually 6 to the power of plus 3, so it's z to the power of 9. And so then we have these two negative exponents. And so that means we are flipping them downstairs. We keep the positive one where it is. We're going to write the positive version of these two powers down here. All right. So, lastly, we'll move on, and we'll take a look at some questions that involve negative exponents, positive exponents, and bedmass as well. So we're going to do all of our bedmass steps, brackets, including anything on the top or bottom of fraction, which we're going to include as a bracket, just like we did in the first question. Distribute all exponents, that's like an exponent step. Multiply or divide, and lastly, we got to make sure that any negative exponents, we got to flip them around. Flip the positives down to the bottom, bottom down up to the top. All right. So, check brackets. Can we do anything inside brackets? Not really, but we do have a pseudo bracket step, a kind of bracket. We have this idea that we have the thing on the top of a fraction. The top of a fraction, actually, we could multiply these things together if we want. So the first thing I'm going to do is multiply these together. I'm going to get a to the power of negative 2 plus negative 3. That's a to the power of negative 5. B to the power of 5 plus negative 2, or b to the power of 3, over a times b to the power of negative 1. And then I'm going to do my division step, which is a to the power of negative 5, take away a to the power of 1, or divided by a to the power of 1, will be a to the power of negative 5 minus 1, or negative 6. And b to the power of 3 minus negative 1 is actually b to the power of 4. So that'll give us a to the power of negative 6 times b to the power of 4. And the last thing we'll do to finish off is we'll flip. So we'll take the negative exponent, we'll flip it downstairs, and that'll give us b to the power of 4 on the top over a to the power of positive 6 on the bottom. Okay. All right. So a question like this, so we got to remember there's an exponent rule that says if we have a fraction with a negative exponent, we're going to just rewrite that fraction as being positive, or sorry, with a reciprocal and a positive exponent. So we're going to see if we can use that rule here. So first of all, we'll do any bracket steps. There's nothing inside the brackets we can do, though. So we're going to move on to the exponent step. We're going to take that negative exponent. We're going to flip it around. So we're going to have c to the power of negative 4 on the top over a cubed b to the power of negative 2. All right. And that's all the power of now positive 1. And to say something's to the power of positive 1 doesn't really change anything.
So I thought maybe there was a class or something.
No, it's fine. I'm just recording a video for students. So if you wouldn't mind closing the door on your way out, thank you.
Of course, sorry.
Yeah, no problem. Thanks. All right, so the last thing to do here is to say, well, I can distribute that power of 1, which is to say I'm not really going to change it. So that actually becomes just c to the power of negative 4 over a cubed times b to the power of negative 2. It doesn't look like there's much more we can do, so the last step we'll do is we'll make sure to do some flipping. Flip some things around. We have a negative exponent on the top here, we'll flip it downstairs, and a negative exponent down on the bottom, which gets flipped up top. So then we have this positive b squared as a numerator, and the a cubed lives downstairs still. And then the c to the power of positive 4 also lives downstairs, like so. All right. So, what do we have here? Looks like it doesn't have much we can do on the top or the bottom of that fraction. Nothing on the top or bottom of this one, but or in the brackets really. We can't do any bracket steps, looks like. But we can do this exponent step, which is to rewrite this guy as we're going to flip it and write it with a positive exponent. So the first thing we'll do is that z squared over y cubed times, and I'll write yz, the numerator becomes the denominator, x cubed, and the denominator became the numerator, yz. And we write that with the power of positive 2. And now we're going to distribute that power as well. So that's also an exponent step, a different exponent law. And the question is, which one do we have to do first? Do we have to flip, or should we distribute? Actually, we could have just distributed them, actually. But it turns out this is just a useful trick in general. But your mileage may vary. You may sometimes prefer to distribute. Like if you see a bunch of negative numbers inside here, you want to distribute that negative exponent. That might be a useful way to go. And you can choose your path. Call them little adventure paths. Now we're going to say yz squared, which means y squared times z squared over x cubed squared, which means x cubed times x cubed, or x to the power of 6. Okay, now we'll do multiplication steps. We're just going to multiply straight across here. So that's fine. That's easy. Those will multiply all the x's, but there aren't any other ones. So x squareds and y squareds. And the z squared times z squared becomes z to the power of 4 over y cubed times x to the power of 6. All right, now, I just want to point out here that we have some simplification we can do. And if you learned last year about how to multiply fractions by simplifying diagonally, you actually could have made this a lot simpler. So this is one method you could have gone. Or you could have said, oh, I see that this is y squared. There's a y cubed here. I could cross out 2 of those y's. There's y times y times y. So I can cross out the exponent, leaving 1y. And there's, I'll take away 2x squareds here, and this will leave as an x power 4. And then when we multiply it across, it's simplified. Z to the power 4 over y x power 4. However, now we have to do some sort of, that's actually the answer, if you were comfortable with what we just did there. However, you also might have learned if you multiply fractions and you don't want to simplify diagonally by taking out any common factors, that you have to always simplify afterwards, which is what we're going to do now. We're going to do a division step, which is to say I'm going to have x squared, minus x power of 6, so it's x power of 2 minus 6, times y to the power of 2 take away 3, times z to the power of 4. And that gives us x power of negative 4, y to the power of negative 1, z to the power of 4. Then I have to do a flip step. Take the negatives, flip them downstairs, and that gives us z to the power of 4 over x power of 4y, which is the same thing as this. If you notice, this was actually much faster. So if you actually felt comfortable with what I did there, I would really encourage you to experiment with it. Play around with it and see if you can get accurately to an answer, because it can be much faster than using your exponent rules blindly. There's often a path you can choose that's the fastest, and that really comes from experience, doing enough questions where you sort of get a feel or a mojo for wanting to go one direction rather than another. And you will build that intuition as you proceed, as you continue, as you do more and more of this stuff. All right, so what can we do here? Looks like no bracket steps, but I can do a distribution of an exponent. So I'm going to do that first. I'm going to write that as a to the power of -6 times b to the power of positive, or -2. Times, and that'll be a to the power of -4 times b to the power of 5. Now I can actually just multiply straight across. A to the power of -6 plus -4 is a to the power of -10. B to the power of -2 plus 5 is b to the power of 3. And then lastly, we'll flip. So that means we'll take that -10, flip it downstairs, and what it'll make is b cubed over a to the power of 10. All right. Well, good luck with those, and let me know if you guys have any questions.